students. In the This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. In the previous lecture, we discussed about the IO modules or the basics of the IO modules. So, which are the IO modules available in case of the PLC system? Now, today we are going to start the various types of the IO modules used for PLC system. How many types of IO modules are generally available in market, or what is the main function of this IO module in case of the PLC system, whether it is really applicable for the PLC system, or what is the different allocations of these IO module. So let us start. So basically, in case of the IO modules, there are two types of the modules available. One is discrete input module. Sometimes it may also called as a digital input module. Means to provide basically the input data in the form of digital, that is analog, that is binary information to the CPU system. Generally, these digital input modules is used. But in case sometime analog data is also available in the form of the current or waveform, means we call it as a physical quantity or whatever, the programming languages are also there. So generally we use the another module, that is, yes, it is analog module. So one by one we discuss. So here the types of the IO modules are discrete or digital input module, and these discrete input interfaces sends the non-continuous signal from the field devices. That is, the signals that have only two states. One is on state and second one is off state. On state means the input signal is very high, and what is the off state? We discussed earlier in the previous lecture. When the input signal is low, then it is in off state. So discrete input interfaces basically receives the voltage and current which is required for this operation from the back plane of the rack, which enclosures where they are inserted. The signal that these discrete interfaces receive from the input field devices can be of different type and or of magnitude. For example, 120 volt DC or 12 volt DC. And for this reason, these discrete input interfaces circuits are available in different AC or DC voltage rating. And AC or DC input circuit has basically two primary parts. One is the power section and second one is the logic section. See here, these sections are normally but not always coupled to a circuit that electrically separate them, providing the isolation. As we discussed previously, there is an electronic isolation in between these parts. And the power section of an AC and DC input interfaces converts the incoming AC voltage from as the input sensing devices to a DC logic level signal that the processor can use for in the read input section. I'm repeating this. It is the read input section. Read means the CPU basically reads the input data from the input interfaces through this logical programming, and these interfaces of the power section will convert the incoming AC signal to a DC level signal, and it then passes the signal through a filter circuit. We already discussed in this power circuit, okay, overall PLC system. So which protects the signal against bouncing the electrical noise on the input power line, and this filter causes a signal has typically 9 to 25 millisecond time. The power section threshold circuit detects whether the signal has reached the power voltage for a specified input rating, and if this input signal one exceeds 1 and remain above the threshold voltage for a duration equals to the filter delay, the signal is recognized as a valid input. After the isolation or after the isolation interfaces which detects a valid signal. It passes the signal through an isolation circuit which completes the electrically isolated transmission from a AC signal to a DC logic level signal. And this logic circuit then makes the DC signal available to the processor through the rack back plane data. Now we are moving towards the discrete digital output module. So the digital output module has terminal to which the output signals are sent to active the relay or solenoid, various solid state switching devices just like a motor and displays. This discrete output module receives their necessary voltage and current from their enclosure back to the plane. The field devices which will discrete output modules interface any differ in their voltage requirement, and this voltage requirement means 120 volt AC or 12 volt DC, whatever the requirement from the consumer side. Therefore, the several types of magnitudes of voltage are provided to control them, and the AC output circuit controls primary of the logic and power section coupled by an isolation circuit. And output interfaces can be though of a single switch through which the power can be provided to control and output devices. During the normal operation, the processor sends an output status according to the logic program to the module logic circuit. Let us see here, if the output is energized, that is reflecting the presence of 1 in the output table, and the logic section of the module will be latched, and this sends an on signal through the isolation circuit, which in turn the switches the voltage to the field devices through the power section. This condition will remain on as long as the output table corresponding images bit remains as equals to 1. When the signal turns off, the one that was latched in the logic section unlatched and the off signal passes through the isolation circuit which provides no voltage to the power section, thus de-energizing the output devices. Basically, these switching circuit in a power section of an AC output module uses either a triac or a silicon control rectifier, that is SCR, to a switch power. The AC switch is normally protected by an RC snubber circuit. All of you are familiar with the snubber circuit? It's part of electronics engineering. And it is a metal oxide varistor, that is MOV, which limits the peak voltage to some value below the maximum rating. See here, this snubber and MOV circuit also prevents the electrical noise from affecting the circuit operation. Furthermore, an AC output circuit also prevents the electrical noise from affecting the circuit operation. Furthermore, an AC output circuit may contain a fuse that prevents the excessive current from damaging the switch. And if the circuit does not contain a fuse, the user should install one that complies with the manufacturer specification. This DC interface controls discrete DC load by switching them on and off. The functional operation of a DC output is very similar to that of the AC output. And here the transistors are also susceptible to excessive applied voltage and a large surge current, which can cause the over dissipation and short circuit conditions. Basically, to prevent these conditions, a power transistor is usually protected by a freewheeling diode placed across the load, that is field output devices. Therefore, the DC output may also incorporate a fuse to protect the transistor during the moderate overload. These fuses are capable of opening or breaking continuity or quickly before the excessive heat due to overcurrent occurs. This is all about the discrete or digital model, or how these discrete or digital models can perform their operations in a particular range. Thank you.